shaded pole motor. This is a 4-pole shaded pole motor. The windings are connected in series from pole to pole, and this is connected to supply. Whereas rotor is same as squirrel gauge rotor. The only difference is one shaded band is present in every pole. The direction of rotation in case of shaded pole motor is from unshaded portion to shaded portion. This is direction of rotation from unshaded portion to shaded portion. This is unidirectional rotation. Reversal of rotation is not possible in case of shaded pole motor. Pole construction are similar to tailgate poles. Only shading band is present in every pole. This is simply a short-circuited copper bar or strip, or it can be coil. This copper ring is able to produce rotating magnetic field in the motor. When winding is connected to supply, the current or flux, which is a sinusoidal current, and we are taking 3 positions. One is before 90, at 90 and after 90. This is for one particular cycle. Either it may be positive cycle or negative cycle. So if you take the position T1, at current direction is upwards, and this copper band, within this copper band, flux will induce because of the Lenz's law. This induced current or flux, which will oppose the main field flux. So in this portion where the copper band is present, the number of flux lines is less. In case of non-shaded portion, the number of copper lines is more. So the net magnetic line is in the unshaded portion. At position T2, the current reaches the maximum line. In this case, the flux lines created by the shaded rings is 0. So the total flux uniformly distributed throughout the pole. So the net magnetic line is at the center. When T is equals to T3, that means current is changes its direction from positive higher to towards 0. So at this position, the induced fluxes within this copper bar are in line with the main field flux. So the total flux lines are more in case of shaded portion than compared to unshaded portion. So the net magnetic line shifts towards the shaded ring. So at T is equals to T1, the flux lines are opposite. At T is equals to T2, the total flux lines distributed equally throughout the pole. At T is equals to T3, the flux lines shifted towards shaded portion. So here the shift of rotating magnetic line is from unshaded portion to towards shaded portion, which creates rotating torque. So the motor rotates in this direction from unshaded to shaded. If you compare the advantages, this is simple motor, cheap and less noise. If you take disadvantages, torque is less, speed is less, losses are high, power factor is very low, efficiency is also low. This is only below 35%. So mainly rotating magnetic field is able to produce the required torque. So this is a self-starting motor. So starting torque is not equals to 0. So this is the starting torque which is not equals to 0. This is the speed torque curves. This is torque and this is speed. Applications of shaded pole motor. This can be used in clocks, toys and tape recorders. So if you check the vector diagram, there is only supply voltage and only load current. So phi is the angle between supply voltage and load current. There is no requirement of auxiliary winding. There is only main winding. The main winding carries the current, load current I. So phi is high, so power factor is low.